20 years after becoming industry pioneers in the production of bonded carbon fibre frames, Trek invited inCycle to their combined factory, headquarters and research centre in Waterloo, Wisconsin, for a lesson on how they developed some of the lightest and strongest road bikes in the world.
We have a massive engine here at Trek, an engineering engine. It's what sustains us, and the fuel for that engine is R&D. We prove out absolutely everything we take to production before we take it to production. And the beauty of that is it's really just about science. You make a hypothesis, you develop a piece, you test it, works, it doesn't work, and you start all over again.
Paul Harder is responsible for putting prototypes to the test.
It's more about high-end performance, ride feel of the bikes, not so much is it going to break or are there going to actually be structural problems, but is it going to feel great going around a corner at 50 kilometers per hour? Is it going to feel great in climbing? Is it going to be fast? Is it going to be comfortable? So that's kind of where I come into play and get to play with all sorts of interesting sensors like high-speed cameras, strain gauges, accelerometers, things like that. There's a ton of unknowns in cycling science. Race cars and airplanes are really well studied, but things that go 30 miles per hour are sort of a new frontier in science. So especially in the realm of aerodynamics, vibration, things like that, all those topics at those kinds of speeds and realms are really new and sort of cutting edge. So it's challenging, but it's also really fun because we can really break new ground in science and not just be relying on F1 technology or airplane technology that might not necessarily translate.
One man who knows more about the production of high-quality carbon fibre road bikes than just about anyone else is Trek's Jim Colegrove. He pioneered the company's optimum compaction low-void manufacturing technique.
The OCLV process is similar in some ways to the manufacturing processes that other companies use. Most bicycle companies are using a bladder molding technique, which means that you have a female mold that is the external shape of the part that you want to make. You put carbon fiber into that female shape, and on the inside of that you put a bladder or a balloon. This can be pressurized, and this pushes the carbon fiber out against that mold or the female shape, and after curing creates the part that you want. Really, this is the beauty of carbon fiber, because we can nearly infinitely vary the angle, plies, materials to custom tune, if you will, every part of the bike for the job that it has to do. Minimizing weight, maximizing performance. When we started building composite bikes back in 1992, it was really pretty easy to carve a pound of weight out of like a current aluminum bike or almost 2 pounds out of a steel frame of the era. So just by changing to carbon fiber, using round tubes, simple connections, it was very, very easy to get that kind of weight reduction. Now, over the years, because of competition, because of the weight that we are trying to hit, the weight targets that are so light, we have to use sophisticated finite element analysis. We have to use computational fluid dynamics if it's a highly aerodynamic bike, and then we couple that with the engineering that we have learned over the years to make the kind of product that we can build today.
Unsurprisingly, Trek also has an eye on development with a potential to revolutionize their manufacturing process. 3D printing on an industrial scale.
Additive manufacturing, especially with advanced composites like carbon fiber, is going to be huge. When we can develop the processes that we can use out in industry on a day-to-day basis, not specialty small lab types of things, where it is right now in many cases, it's going to be, it's going to truly be a breakthrough.